Hello everyone, if you want to learn line by line code implementation of this live video demo for object detection, please stay tuned till end of this video. We will be starting from the scratch about the concepts, what is the difference between object detection and image classification, and till end of this video we will be implementing line by line code. So even though if you do not have any prior knowledge to deep learning concepts, what is object detection and image classification, this video is for you guys. For implementation, we will be using Python as a programming language, and for overlaying these rectangles and text data, we will be using OpenCV. Similarly, as we are targeting the beginners level students, so it's in this video we will not train the object detection classifier. Rather, we will be using pre-trained deep learning architecture based on TensorFlow. So in this regard, we will be using OpenCV to load already pre-trained TensorFlow frozen models. Let's get started. My name's Shanullah and I'm a PhD student at Inha University, South Korea, and my major is computer vision and deep learning. At the end of this video, you will also deploy our object detection algorithm for live webcam demo. So okay, before diving into the implementation, let's have some brainstorming. As you can see over here that this in this image we can see that there is a dog, there is a grass and background as well. But if you give this image to any deep learning classifier such as AlexNet, GoogleNet, MobileNet, this will be classified as a dog. Why? Because dog is the most salient feature of this image. Even a human will definitely classify this image as a dog. Similarly, for this image, we will classify it as a fish, right? Because in this image, the most salient feature is fish. Similarly, in this regard, dog is the most salient feature and elephant is the one which is most salient. But what about this image? It will be unfair if we classify this image as a dog or a cat because both of them are the most salient features. So this is the problem of this video, right? So the solution to this problem is object detection so that we can classify both of them and localize. So for simple image classification and recognition, most of the classifiers are AlexNet, GoogleNet and MobileNet and VGGNet, right? And many others as well. So in 2012, AlexNet was the pioneer of the image classification challenge, which beat the human capacity by 150%. So it was a major breakthrough in the deep learning. So after that, many deep learning architectures are revolutionized day by day. The famous dataset used for image classification is ImageNet, which contains 1000 classes. So, however, for the object detection, the famous dataset is COCO having 80 classes. So as you can see, the object detection is basically a combination of classification and localization. So for example, in this regard, we will use two algorithms. Like we will be using the combinations of two or more algorithms, right? So for example, MobileNet was the image classifier in previous we can see that in previous slide we have shown that MobileNet is the image classifier, right? So we will be use single shot multi-box detector, the combination of these two for a better object detection. What happened in it? For example, there is an image, right? So what single shot multi-box detector do, right? It classify for example, it divides all the image into small patches, and then combination of the patches based on the most salient feature, it joins those patches and ask the classifier, okay, like MobileNet and other whatever is the combination. So it asks the classifier to classify this image. For example, in this case, if there is a cat and dog image, what SSD MobileNet does that it will divide into different patches, and then combination of the patches it will make a most salient one, and then it will ask for from the classifier, right? So right? So it will ask from the classified. So it is the combination of two algorithms. Similarly, we do have other algorithms like YOLO, you look only once, which is also a very famous one, but the most lightweight and faster one is SSD mobile net. And in this regard, the most recent one is SSD mobile net version 3, which is among all, like version 1, version 2 and version 3 is the best one, right? So now we have defined the problem, that what is object detection. Now let's dive into implementation. But before diving into implementation, another very important concept is image segmentation. So these are the three important concepts, like image classification, object detection, and then image segmentation. So what is image segmentation? So image segmentation is to classify, rather than classifying an object, it is to classify each pixel. Over here you can see that, for example, this is a person, right? So every pixel has been classified, right? It shows like red, so all the persons in this video is shown to be red. Similarly, the data set is different, like cityscape. Previously, for the object detection, the famous data set is Coco, and for image classification it is ImageNet. So definitely we need to care about the data set as well. But in this video we are targeting only the concepts and just the implementation. So let's dive into the implementation. The ingredients we will be using in this video is, for example, Anaconda, which is the package containing different IDs. ID is the one in which we program our code, right? So we do have Spider, we have VS Code and Jupyter Notebook. But we found the Jupyter Notebook the best candidate for this tutorial. Why? Because we can make notes and a lot of other features we do have in the Jupyter Notebook. You will see in this video. After installing Anaconda and Jupyter Notebook at the end of this video, after installing these two, we will install OpenCV. Let's get started for the implementation. In order to install Anaconda, all you need is to just write in this Google search bar, download Anaconda, and once you write it, you will find the first link. If you click the first link, you will find at the downside of this link many executables. So based on your specifications, either you are using Windows, Mac OS and Linux, you can just download the corresponding executable, right? Once you download, all you need is to just press next, and it is super simple to install. Now I assume that you have already installed the Anaconda. So in the Windows search bar, if you write the Anaconda like this, so you will reach here like Anaconda Navigator. If you press the Anaconda Navigator, you will reach to this page. Over here you can observe that we have green buttons with install instruction and blue buttons to launch, right? So in your case, as you install the Navigator, so all of them will be green, and you can just click the install button of the Jupyter Notebook. Now I assume that you have installed Anaconda Navigator and Jupyter Notebook. Once you installed both of them, it's better to create a new folder, right? So in my case it's full, but in your case the folder will be empty, right? So create an empty folder for your project. Then again you should write Anaconda, and this time rather than clicking Anaconda Navigator, you should press the Anaconda prompt, right? So once you click this, let me zoom for you. All you need is just cd and paste the path, and then change the drive and just write Jupyter Notebook. Once you write the Jupyter Notebook, okay, so a window will be appear like this, right? So all you need is to just create a new Python Jupyter Notebook, and let me separate for you guys. Okay, the first thing we need to do is to import OpenCV, right? So import CV2 is the command. In order to install OpenCV, definitely at this moment you have installed the Anaconda Navigator and the and Jupyter Notebook so far. So pip install OpenCV-Python is the command to install the OpenCV, right? So all you need is to just visit Anaconda prompt again, and this time make sure that you run as administrator. Once you run it, all you need is to just copy this command and just run it, right? So OpenCV will be installed. Okay, the second tool we need is to import matplotlib.py as plt, right? So in order to install this, you need into pip install matplotlib, right? So again, like run as administrator, then a conda prompt, and just write this command, and you will be good to go, right? So now I assume that you have installed these four candidates, such as, for example, the OpenCV and matplotlib. Okay, so let me tell you how to start, where to start for the object detection, right? Okay, so this is the OpenCV page, official GitHub link. I will provide in the video's description. So once you visit over here, you will find many deep learning architectures already pre-trained models available, and they are based on TensorFlow, right? So they are based, although they are based on TensorFlow, but you can just download and you can use OpenCV to load them. That's what we are going to do right now. So the most recent one is MobileNet SSD version 3 that is discussed in the beginning of the video. So all you need is to just write and save link, okay, or you just click click it, so it will be downloaded, right? And another important thing is, one are the weights, like your deep learning architecture, and the second thing is your configuration. If you click to the configuration, you will be here, right? So as you can see over here, what is the configuration, like what is the input size, and a lot of other information is available. So you need to load it as well. So just download zip, right? Once you download zip, for example, let me download for you guys. So once I press download, it will be download with some name like this. So in my case, I have already downloaded and copied in my folder, like this is my graph and this is my okay, so this is the version, this is the graph of the deep learning architecture which I have recently downloaded. So once you extract the folder, you will find a lot of them. So the most important one is frozen inference graph. All you need is to just copy and paste it wherever you are going to use. So this is my project folder. I just created this untitled new Python notebook, so I have just placed over here, right? So in any folder you can place wherever you are working, right, in the project folder. Similarly, if you visit this, if you extract this to the graph configuration, you just need to copy this configuration and just paste it wherever you are working, right? So now, as I have these two candidates inside my folder where I'm working, okay, so I can just load it, right? Okay, so let me load them. So let me give them names. For example, my configuration file is this, and secondly, if you have in any other folder, you don't need to copy, so you can just provide the path right over here. So in my case, I have copied in my main folder, so I need to execute. So before diving it, it's better, for example, okay, let me load the model. So the model is equal to, sorry, cv2 dot DNN. If I press the tab, I will have multiple options, right? So the most important one is the DNN detection model, right? So there is one method, and the second method is, for example, if you write cv2 dot DNN, sorry, DNN dot for example, if you press a tab, and then you can just read from the TensorFlow as well, but I will follow the like this method, right, not the run from TensorFlow, but we do have another method as well. So in this case, I can give the frozen model is the first candidate, and the second candidate is config file, right? So now, okay, so now in my memory, I have loaded the TensorFlow pre-trained model, right? So this is my model and this is my configuration file, right? So once I have loaded my model, so another important thing we need to have is this darknet, right, labels. So in this case, all you need is to just for example, I will also provide the link of this darknet cocoa names. Okay, so all you need is to just copy all of them, right? So there are 80 classes, as I told you before. In the cocoa dataset there are 80 classes, right? So these are the labels. So Once you have, for example, I have already the labels. Okay, these are my labels. So let me show you what are my labels. Okay, so I've just copied in a text file. So all you need is just create a text file like this. Okay, create a text file and just copy all of the labels, right? So now the third thing, I assume that you have already copied the labels, right, and just download it. Okay, so once you download the labels, why we need labels, right? So in order to check our answer is correct or not, right? So that is why we need labels. Okay, so let me write a code for you for loading. So label.txt I have just copied in my folder, right? This is my label.txt containing all 80 classes. Okay, so I can just execute like this. I can also do using a pen, but I'm over here, I'm not using doing it using a pen, but I'm just doing it like I'm reading the label and creating the list of Python and just doing it like this. So let me print for you. If I print the class labels that have already been appended, so you see we have a list of this all 80 classes, right? If I check the length, like this, if I print the length, there are 80, right? So we have 80 classes, and now we have successfully loaded the model, and now we are good to go, right? So for doing it, let's read an image, right? Okay, so in order to read an image, what we need, okay, so the good thing is to solve, we can just convert, right, into nodes, right? So in order to read an image, okay, we can just read any image, right? So this is the command cv2.imread. Okay, so before reading the image, the one very important thing we need to consider, if you check the Google over here, as I showed you that in the configuration file, if you visit the configuration file, in the configuration file you can see that the size is 320 by 320, right? And there are many other changes as well. So what we need to do is over here, if I load, for example, this image, and let me show you plt.im show image. So oh, sorry, I think I haven't copied this image. Okay, let me check either this image exists or not. Okay, this image do not exist. So let me load this image. Make sure to have the image inside your folder. Actually, I was okay. Okay. What is happening? It may be not PNG. So let me check either it's PNG or JPG. So you see over here it's a JPG format, right? Let me view it for you guys. Large icons. So it's a JPG file, right? So make sure that to put the right format specify as well. The format should be same, right? If I write like this, then you see over here. So now it's a BGR actually. So we have BGR, right? So blue, green, red is the by default using OpenCV, right? So if I convert into like this, so you see over here, if I convert it into RGB, this is the actual image, right? So these are the thing, like we need to convert BGR to RGB and many other settings we need to do, right? And as I showed you that we have a 320 size, right? So this is the configuration we have just loaded, right? So this is the configuration we have loaded, you see. So this is the configuration. So now the total configuration, right? If I press model, okay, let me to save my time. Okay, so model dot you need to do like this. So once you loaded the model like this using this command, so another thing important, you need to set up the configuration. So input size is 320 by 320. Why? Because in this configuration file we have defined it's 320 by 320, right? And another thing is that 255 divided by 2, 255 is the gray level for white, right? So 0 to 255 is the mostly gray level. So it's we are converting it to for scaling, we are doing it, right? So another thing is that is 127.5, we are taking the mean. The why is so because mobile net, this mobile net takes the input as a -1 into 1, right? Okay, so this is the reason why we are doing it like this, right? So it takes -1 into -1, right? So you have to take care of the configuration of your architecture. Similarly, we have set input swap RB. So as you see over here, we did like this, like BGR to RGB. So we don't need to convert it each time, right? So it should be automatic. So when we did swap RB true, so it will be automatically did by itself, right? It will perform automatically. So now once we do it, okay, so the most easy thing is, okay, so once I have model, so I can just, you see, I can just write model dot detect. You see, so if I press the tab, it will be automatically done, right? Because I have already loaded the model. So class index, conference, bbox. So this is the three output of this, and this is the threshold based on your accuracy you want. If you want to have more accurate, then you can reduce and you can change it. We have just fixed it for 50% confidence, you see. So if I print my class index, so there are two things like 1 and 3. So what is 1 and 3? So if you see over here, 1 is actually, if I start from 0, it is 1, so I will reduce -1, I will show you. But this is 1 and this is 3, right? So 1 is person and 1 is car. So you see, we have two labels, one is person, one is car, right? So it successfully detect. So if I check, you see over here it is not flattened. So in order to do it, so we need to flatten it, right? So you can see over here we have two lists, right? So we have to flatten before doing it. So okay, so this is the code for, like, for example, I'm setting my font, what is my font size and what is my font type, and then I need to have a loop like class index, conference, boxes in zip. So if we have three different folders, sorry, three different variables, we need to do zip, and everything I'm flattening. Why? Because they are double braces, right? So that is why I'm doing it for flatten. For bbox it's not, so that is why for the box we are not doing it. And we can have different like cv2.rectangle means that plot this box having bgr, right, blue. So the rectangle color will be blue, and this is the scale. And similarly we have put text, like this is my text, whatever I write over here, it will be displayed over here. So the class index, the class label, we have class labels, right? We have 80 class labels, you see. In the class labels we have this, so we want to display this one, right? But it is at 0th index. So as you can see over here, there is a offset of 1 over here, see. So I need to reduce -1 over here. So once I execute this command, and similarly the font color is 055, so bgr. So font color is green and bgr, and the rectangle color is blue. So if I shift enter and execute it, then I need to plot again. Let me plot again my image, right? So I have modified my image. You see, now you can see over here that it has detected the person and the car, right? So very efficiently it detected the person and car. Now as we can process one image at a time, now it's time to go for the video demo, right? In order to deploy this code for the object detection in case of the video, all you need is to just write this code like cv2.video capture. So it will just load this mp4 video file. So it mostly support mp4 and other formats, you need to check. And once you do it, you need to write this code. For example, if it is corrupted or you cannot uh, open the video, so these are the commands. And similarly, this is the same, like for scaling my font, and this is the type of my font. And you can do it while true, like one, but you can do it till end of that as well. But right now, for the simplicity, I'm having infinite loop. So what is this, like cap cv2.video capture is a file pointer to this video, like it will be pointing to the first image of this video. So the video is nothing but it's the combination of the images, right? So usually we have on average 25 frames per second, right? And for high resolution videos like 4K and others, we have 60 frames per second, right? So video is nothing but a combination of images. So we are reading cap.read. Okay, so now then we will have image in it, right? So as you can see over here, previously we just have loaded the our model based on our configurations and the frozen graph, right? And we do have all the labels as well, so all the settings we have put before that. And now if we write this command, right, model.detect, so I have executed already these commands, so that is why I'm not doing it again. So all I need this command. Okay, so I'm just doing it, right? So in your case, if for example, if you haven't executed previous commands, you need to do it, right? Because model will not be safe in your case, so you need to execute these commands. So I assume that you have already executed all previous commands. So model.detect, now in this case, rather than image, I should have frame. So frame by frame we are reading the video. And then for example, in this case, we need to make sure that must not be 0, right? So there must be a frame in it, right? So we are double checking over here and over here as well. So now this is the previous code. Okay, but one more extra condition I have just put, because sometimes it gives you an error, or it more than 80 classes and other things. So make sure that class label must be 80, because we have only 80 classes, right? So we have only 80 classes. So I'm just in order to avoid crash the video, so that is why. And again, similarly, the color of my rectangles are blue, and the color of my text, that is green, right? So bgr, right? So now if I execute this, so this is the video, I'm just doing it. Let me show you the video first. Okay, so this is the video, right? As you can see, I have just recorded this video from YouTube. Okay, so you can just record your video as well from YouTube or anywhere. And even if you do have your own video, you can just process it. So if I execute this command, you see over here, this is the same video, the same person who was coming right now. So over here you can see that in the start I showed you this video, so as well. So it is detecting perfectly person, car, and all others, and it is doing it like right. So we have a while one, so it should not be while one, but anyways, it is perfectly working, right? So the same code we just run. So you can download it. You see that when the bus comes, it is detecting the bus, and the car comes, it is detecting the car. So now it's time to have a webcam demo, right? In case to have a webcam demo, live webcam demo, it's better that you just, for example, you modify the previous code into one, right? So in my case, I have only one webcam. So based on the number of the webcams you have, so you can change this code, but it's dynamic one, right? The code is very dynamic, so it is finding 0 or 1. This is, for example, this is webcam. So all you need is just change this is just my error instruction. So the most important one was that you need to change it to 1, right? So once you do change it to 1, the rest of the code is same. If you execute it, you see it can successfully detect the person, and if I move, you see if I move, so it can detect it as well. So it's real-time demo. In your case, I assume that you might have other objects as well, so you can just try it using multiple objects in your using your webcam, and you can just deploy real-time webcam demo. Thank you so much. Thank you for watching this video.